These are notes on 7.1. First, we're looking at just conic sections. So chapter 7, the entire chapter is about the study of conic sections, and that comes from these different cross sections of this double cone. So you can see how depending on how we take the cross section, we could get a parabola, a circle, an ellipse, or hyperbola. So that's why we're studying and grouping all of these shapes together. I also have this general form for any of these shapes. So obviously, if we're looking at a circle versus a parabola, I mean, our A and C, we could have one of them equal to 0. So you can have one of those letters equal to 0, or more than one of those letters equal to 0 for those constants. A, B, C, D, E, and F, constants or coefficients. But they're all going to be able to be written in that general form. So this is what we're looking at right now. For the entire chapter, we'll be studying these kinds of shapes. So today we are looking more specifically at parabolas. So first we're going to look at the standard form for a parabola, and it's going to be different than vertex form that we've worked with before, and different than like ax squared plus bx plus c equals 0. So by definition, a parabola is a curve where all points are equidistant from focus and directrix. So if this is my parabola, then my focus is inside. It always is opening towards that focus, and the directrix would be over here. And that means if I have a point on my parabola, it's going to be equidistant from the directrix and the focus. So that's what the definition of it is. So it means this. So we're going to look at the different ways. We could have a parabola that opens up and down. We could have a parabola that opens right and left. So first we're going to look at the classic example of a parabola that opens up. And this is a really messy one. So my vertex is at the bottom. My focus, and I usually use F for focus and V for vertex. My focus is going to be P units up from the vertex. We'll talk about P in just a second. My directrix is going to be P units below my vertex. And I feel like I could move that there, make it look a little bit closer to being the same distance. And the equation would be something like x minus h squared equals 4p times y minus k. So my center, or not my center, my vertex, I was just looking at circles, so I was thinking about centers. My vertex is going to be hk. So that's just like before when I had something in vertex form. I'm still using those same letters, h and k. And then you can see where p becomes important. This 4p, 4p is my coefficient of the quantity y minus k. P is that amount that I'm up from the vertex or down from the vertex, that I'm coming up with the focus and the directrix. Let's write down directrix here. So if we were going to list out some of the other characteristics, if I am talking about my focus, I know it's that same x value h, but now it's up p units from my vertex, so I'm going to write down k plus p. My axis of symmetry, we still care about that. If I was going to draw my axis of symmetry, the axis of symmetry would be the line that the focus and the vertex lie on, and that would be x equals my x value at the vertex, x equals h. And the last thing would be my directrix. My directrix is a horizontal line, so it'll be y equals, and it is p units down from the vertex, so it will be at k minus p. One more thing to add here is that if p is negative, maybe we'll add this over here in red. If p is negative, that means it opens down. So the other kind of parabola that we're working with now is parabolas that open right or left. So before, we always worried about these ones that opened up or down. Occasionally you would see one that opened right or left, but it was kind of an anomaly. and we're going to do a lot more with them this time. So if my parabola opens to the right, it still opens towards the focus. So my focus could be right here. And remember, the focus is still p units away from the vertex. My directrix is still p units away. This is my directrix. We usually use capital letters for points, and we use lowercase letters for, I thought I could move that F and make it look closer, but I can't. We usually use lowercase letters for lines. I notice I'm putting these off in space. I'm not putting them on an XY, on an ordered plane or anything. So on this one, it's going to be in the form y minus k squared equals 4p times x minus h. So notice x is still with the h and y is still with the k, but they're swapped. They're on different sides because now my y is being squared. So I have basically like an x equals y squared parabola. So my vertex is still hk. My focus this time is going to be to the right of my vertex. So I'm changing that x value. Instead of h, it's going to be h plus p, comma k. My axis of symmetry is now a horizontal line. So it will be y equal, and my y value at my vertex is k. And my directrix is a vertical line, so it will be x equals, and it is p units to the left of my vertex. So my vertex would be at k, so I'm going to, or sorry, my vertex would be at h equals, or sorry, x equals, I'm going to go back to my marker here. So I'm starting at my h, but I'm subtracting p. So I'm starting at this vertex that was an h value, and I'm going to the left p unit, so it's h minus p. And I still don't like, it's like I wrote directrix, and then I thought I had the x already there, so it looked really weird. I was trying to figure out why it looked strange. So that's going to be x equals h minus p. So really when I'm graphing, this is a lot. I think it's good to understand how they work. Oh, and we should add here, if p is negative, opens left. But I try not to memorize too much of this, because a lot of it we can figure out by looking at the graph. And we'll go through that with the next couple graphing problems. So this is what they give in your textbook. It's just basically what we went through, but it is there for reference. And example 1, we're going to actually go through and practice this graphing. So first thing I notice right away, this is a negative. So we know it's going to open the opposite direction we just looked at. Let's see, I have x on the right. The left-hand side is y squared. So this is going to be one of those parabolas that opens right or left. It's negative, so it's going to open left. So it's going to look like this. This means opens left. So I'm always kind of coming up with a little drawing in my head about what's going on. So if my parabola opens that way, my focus is inside it, my directrix is out here. And I always make that little graph just to think about what I'm doing and kind of orient myself before I start. So my first step would always be finding the vertex and P. So that's what I'm going to do first. Vertex and P. So my vertex is going to be a -1, +3. And let's see, 4p would equal 8. I'm not worried about the negative. I know the negative means it opens to the left. So p equals 2. And now I'm going to graph to get the rest of my characteristics. Now graph to find characteristics. Let's see, -1, 3 is right here. And if p is 2, That means 2 units to the left, I will have my focus, and that means 2 units to the right will be the directrix. So we'll call that lowercase d. So now I can go ahead and list out all of this information. So my second step is listing it all out. I've got my focus that is at -3, 3. Let's see, my directrix is at x equals 1. And my axis of symmetry, can't forget about that. That would be a horizontal line through those points. So y equals 3. And we are doing no tables for graphing. The book is going to show some tables for graphing. We are going to use the lattice rectum to find the other points on my parabola. So the lattice rectum, and I swear that is not a made-up name. You can look it up. Is a chord through the focus with length 4p, and the endpoints are on the parabola. So let's just draw a quick little picture of what this would look like. So if I have a parabola like this, and here is my focus, and here is my vertex. So I know that this is p units here between my focus and my directrix, and I know that there is a chord through the focus that has endpoints on the parabola. And I know the whole thing is 4p in length. So that means 2p on one side of the focus and 2p on the other side of the focus. So let's add that in here. 2p on each side of the focus. So in order to draw a parabola, I really need more than one point. So I have that vertex that I know is that I go up p units to get to my focus. And then I can go 2 units or 2 p's, whatever that is, to the right, and 2p to the left, and that will give me 2 more points on my parabola. So when I'm graphing, I'm essentially connecting my vertex, and then this point on my endpoint of that chord, and this other point. So they're always going to make that pattern. So we're going to try that out on our graph right here. So our last step is going to be using that lattice rectum to find more points. Really, we could have swapped step 2 and 3. But I thought we would save the more vocab for the bottom of the page. So p is equal to 2. So that means from my focus, I need to go 4 units because 1p is 2, so 2p is going to be 4. So we'll go 4 units up and we'll go 4 units down. So again, that means this is p and this is 2p and this is 2p. So if p is 2, then I have to double that and go 4 units down for my focus, 4 units up for my focus. And then those 3 points are the points I'm going to connect and actually draw my parabola. So that is giving us a way to find more points on the parabola without actually doing a table, because we don't want to do tables. And we want these nice whole number points as well if we can afford it. So for our second one, we're going to have to write it in standard form first. So I need to get my y over with the 18. So x squared minus 8x equals y minus 18. And now we're going to have to complete the square because I need to have a squared quantity here. So half of 8 is 4, 4 squared is 16, so I need to add 16. And I have to add it on both sides. And then I need to factor. Y minus 18 plus 16 is y minus 2. And remember, we could think of this as having a 1 in front if we had to. So to graph, the first thing I want to do is find my vertex in P. So my vertex is 4, 2. And if this number in front of my parentheses 1, that's going to equal 4p. So p is only 1/4 here. So this is going to be a really difficult graph to do. The units are going to be really tight. The other thing I want to do is kind of think about the shape. So I have y on the right and then x squared on the left. And p is positive, so it's going to open up. And my focus will be inside and my directrix is underneath. So I have kind of a little idea of how it will look. So let's go ahead and do this. So 4, 2. And then my focus is 1/4 of a unit up. And my directrix is 1/4 of a unit down. So I know it doesn't really look like 1/4. It looks like more like 1/2 there. So before I start trying to graph the rest of it and use the lattice rectum, I think I am going to go ahead and list out some of these characteristics just because as I graph it, there's going to be a lot more stuff kind of tightly packed around the vertex. It'll be hard to read. So my focus I know is just 1/4 of a unit. P is 1/4, so it's 1/4 of a unit up from my vertex. So it'll be 4, 2 and 1/4. My axis of symmetry, thankfully, is going to be easy. That's going to be a vertical line that my parabola would be symmetrical through. So that would be at x equals 4. And let's see my directrix. So if P again is 1/4, my directrix is 1/4 unit down. So instead of at 2, it will be at 1 3/4. And that is a horizontal line, so it's y equals 1 3/4. So I'm going to, in some scratch paper over here, just kind of show what's going on, again with the lattice rectum. So if my vertex is here, and my directrix is down here, and P equals 1/4, and here's my focus, and I know that the length from my focus to those points that are actually on the parabola is going to be 2p. So this is 2p here, and this is 2p over here. So the whole length of it is 4p, but it's 2p on each side of the focus. So if p is 1/4, then 2p is going to be 1/2 this time. So I need to only go over half a unit to the right and left of that focus to come up with those points on the lattice rectum. So this is going to be a really tightly packed, tiny looking parabola. So, well, I think it's good practice for us to try some like this on our homework. This would be a really difficult problem to grade on a test, so you're probably not going to see anything like that there. So now that we've had practice graphing, one of the things that you'll notice in this chapter is whatever shape we're looking at, we practice graphing it, and then we look at working backwards, and we're given some characteristics, and we try to find the actual equation. So whatever information they give me, I always graph it. I'm very visual. I like looking at a picture, and a lot of times it's going to be easier. So my focus is at 2, 1, and my vertex is at -5, and then 1. So if my vertex is here, oh, sorry, other way around. Vertex is here, focus is here. It always opens in the direction of my focus. So I know it's going to go like that. So that gives me some important information. So if it opens to the right, I know it's going to be something like y minus k squared equals 4p times x minus h. So in order to write an equation for a parabola, I really need my hk and I need p. So I'm going to erase this ugly looking f. We're going to fix that really quick. So right away I can tell my vertex gives me hk. And then I know p is that distance from my vertex to my focus. So I need to look at what the distance is here. And I went from -5 to 2, so the distance is 7. So p equals 7, and 4p will equal 28. So now I have everything I need. I can go ahead and substitute. Y minus 1, the quantity squared. This will be 28. And x minus -5 is an x plus 5. For part B, they give us a vertex and directrix. We really like having the vertex here. So I'm going to go ahead and do a quick sketch again. My vertex is at 3, -2. And my directrix is y equals -1. So again, my vertex is going to be HK. I guess I need to figure out which way this is opening. So it's going to open away from the directrix. So it's going to open like this, upside down. So I'm going to have something like x minus h squared. P will have to be negative, so I'm going to go ahead and write -4p. I wouldn't have to put a negative here. I could just remember later, but it's going to help me remember y minus k. And so I know hk already. I'm given the vertex, but I need to figure out p. So my distance from my directrix to my vertex, let's see, this one's at -2, this one's at -1, is just 1 unit. So p is equal to 1. That means 4p is equal to 4. So in my equation, I will write down the quantity x minus h squared. Oh, not x minus h anymore. We have to substitute. So h is 3 equals -4 times y plus 2. All right, and our last problem is I have the focus and I have a point it contains. So this one's going to be a little bit trickier. We're going to do a little bit of algebra in this one. So let's see, -1,7. I'm trying to figure out like how big I need to make this graph. So let's try it like this. So -1,7. And you can tell this is not highly accurate. I'm just getting an idea. This is going to be my actual focus. And it says that the graph opens up and it contains 3,7. So it's going to be something like this. But I don't know where my vertex is, and I don't know where the directrix is. All I have is this point, this 3,7, and I have that my focus is -1,7. So I want to think about from my focus to my vertex, could I figure out the coordinates of that vertex? Well, the vertex would be at -1, and it would be p units down. So I'm going to write -1, comma, 7 minus p. So that is going to give me an hk, and my point is going to be an xy. And I am going to use this equation. This is going to be step 1. I'm going to look at the equation. So if it opens up, it's going to be x minus h squared equals 4p times y minus k. And I'm going to substitute all those values I have, because really what I need to do is find p. If I have p, I have everything else. And so now that I have my vertex in terms of p, and I already have a p in here, if I substitute everything in, I'm going to be able to find that. So my x on that other point is 3, so 3 minus. So step 2 is going to be substituting everything in. I guess step 1 was really a picture, huh? So step 1, we'll write picture. So step 2 is going to be to substitute. So 3 minus a -1 squared, 4p, and then instead of y, we have 7 minus, and k is the quantity 7 minus p. So now I have 4p times 7 minus 7 plus p, and this will be 4 squared. Let's see, so on the left we have 16, on the right we have 4p times p, so 4p squared. So 4 is equal to p squared, and then square root both sides. So 2 will be the absolute value of p. Don't forget about absolute value. So net plus or minus 2 will equal p. And then because we're opening up, we're going to use the positive value. So since it opens up, p will equal 2. We're going to actually reject -2. Because again, our graph is opening up. So if our graph opened down, we would accept the negative value. We would reject the positive one. So then my third step is going to be just to go through and figure everything out. My vertex and p, that's really what I need. and then we'll write the equation. So I know that my vertex is -1, 7 minus p, and I found that p was 2. So -1 comma 5. So that's going to be my vertex, my HK. And I know that p is equal to 2. So 4p is equal to 8. So now that I have that, I have everything I need to write my equation, and I'm going to go ahead and do it in red so it really sticks out. So I will have x plus 1 quantity squared equals 8 times y minus 5. So this is really the end of our 7-1, our parabola notes. I just want to point out that this tangent line stuff, well, I think it is wonderful because of the time constraints this year and the pace that we're moving at. You are just going to skip all of these problems asking you to find equations for lines that are tangent. So while I really enjoy these, I think it is just not the best use of our time this year. So you're going to be skipping some stuff on the homework when it just doesn't look like what we've done in class together. Have a great night.